In today's lesson, I want to give you an introduction to common logarithms. Our objectives will be to define common logarithms, to introduce inverse properties of common logarithms, and to calculate logarithms by hand. So let's begin with the definition of a common logarithm. And let me start by telling you that when I use the phrase common logarithm, I'm talking about a base 10 logarithm. So if I write the definition, it is log base 10 of x is equal to k if and only if x is equal to 10 raised to the k power. The base is indicated in this definition right here, but I need to make sure that you understand the base is not required to be written there. Like when we deal with radicals, in this one I have a cube root because I wrote an index right here. But if I write a square root, I'm not required to write it. The index is still there and it's understood to be a 2, but you just don't see it written. Well, in logarithms, it's exactly the same. If there is no base written here, it is understood to be a base 10, a common logarithm. Now, I know that this definition can look like a lot of mumbo-jumbo to you, so let me see if I can give you an example that will help you understand it a little more. In this example, it says log base 10 of 100 is equal to 2, if and only if 100 is equal to 10 squared. Well, let me ask you a question. Is 100 equal to 10 squared? Well, sure it is, because 10 squared is just 100. So what that says to me is that the log base 10 of 100 is equal to 2, because this is true. I still know that that's a little cumbersome for you to use, so let me tell you about the inverse properties of logarithms because they're a little easier for you to handle. Let me put the definition here first so we don't forget it, and then let's look at the two inverse properties of common logs. The first one says that if you have a log base 10 of 10 to the x, that is equal to x for any real number x. Let me say that for you in English. When you're doing logarithms, if you see that this base, that's the base of the log, and this base, the base of that exponent right there, are the same number, then what you get is the exponent. Let me say that one more time. If these two bases are the same, then what you get is the exponent. And that's what's going to really make this a little easier for us to deal with it. There's another inverse property as well. This one says that 10 raised to the log base 10 of x power is equal to x. And it's very similar to the other one. I know it doesn't look like it, but it really is. Because what you have here is a base for that exponent, and here you have the base of the log. When the two bases are the same, what you get is that number right there. And I do want to point out to you that that is a positive number x. Now, using this inverse property, let's see if we can make this simplification here a little bit easier for us. Log base 10 of 100. Would you agree that I can rewrite 100 as 10 squared? And the reason I do that is because I want to make these two bases the same. Because if that's what happens, then I will get the exponent. So it's perfectly okay for me to rewrite 100 as 10 squared. Then the log base 10 of 10 raised to that power gives me 2. I think we'll need a little more practice with those, so let me give you some more problems. This time I want to do the log base 10 of 1,000. Once again, the question is, can I rewrite 1,000 as 10 to some power? Well, the answer is yes, I can. It would be log base 10 of 10 to the third power. Remember, according to that inverse property, if these two are the same, then what I get is that exponent right there. When you take a log, what you get for an answer is the exponent. Let's do another one. This time I have log base 10 of 1. Now that one may be a little harder for you to see, but let me ask you, is there any number that I can raise 10 to that power and I will get a 1? Well, the answer is yes, there is. You may not remember it, but what about 10 to the 0 power? Remember, when we raise 10 to the 0 power, that is equal to 1. So now I have it where this base and this base are the same. So tell me, what is the answer? 0. Let's do one more. What about log base 10 of negative 10? Well, once again, what I need to do is to write 10 raised to some exponent that will give me negative 10. Well, there is no number that I can put right here that when I say 10 raised to that power, it gives me a negative number. So the answer this time is no solution. Let me say that a little bit more clearly for you. We cannot take the logs of negative numbers. Anytime we see a situation where we're taking the log of a negative number, your answer to me will be no solution. But what happens when we have a number that cannot be written as a power of 10? But let's go one step further with this to logarithms of numbers that cannot be written as powers of 10. For them, we'll need to use the calculator. For instance, if I want to calculate the log of 15, I cannot write the log base 10 of, and I can't make this happen where this is 10 to some power and I get a 15. So that doesn't work for me. So what can I do instead? Well, I can go to my calculator and I want to do log of 15 on the calculator. By the way, that log key is 6 keys down on the left-hand side of your calculator if you're looking for it, and you want the one that says LOG. It'll open a parentheses for you, enter the number you want to find the log of, and then close the parentheses. It'll come back with your log. In this case, it is 1.176091259. Now let me make sure that you understand what that means. That means that if I take 10 and raise it to that power, what I should get is 15. Why don't you grab your calculator and try that right quick? And now we've got a little rounding here, but you should be getting something that's really close to 15 when you do that. By the way, that's not a number that I would have known just off the top of my head, but my calculator could find that for me. By the way, my calculator could also have done the ones that we did on the previous page, such as log of 100. We know that it's a 2 because we just looked at that. But let me also tell you, your calculator could have done that just as easily. Log of 100, close parentheses, and then enter, and it should give you the 2. If logarithms are not something you're familiar with, if you haven't used them in a while or maybe never at all, I would suggest that you practice a few of these to kind of get a feel for that a little bit more before you move to the next section. Let me leave you with my thought for the day. It's easy to be brave from a safe distance. I'll see you again next time. Bye-bye.